we're given the point negative 5, 3 that's lying on the terminal side of an angle. And with that information, we had to evaluate the 6 trig functions. So first up, let's go ahead and plot that negative 5, 3. So from the origin, negative 5 up 3, here's our point. Now since this is lying on the terminal side of an angle, let's just remember that angles come from the origin, and that point is on the terminal side. So what we're going to do here is make a triangle, and we're going to use the point they gave us, and the triangle always goes to the x-axis, always, always, always about the x-axis. And here we have a nice right triangle, and theta is at the origin. So we can go ahead and label our 3 sides, or what we know of them at least. I know from the origin to the left has a distance of 5, but because we went to the left in the negative direction, we're going to use a negative 5. The other side of our triangle is a positive 3. And now we just have to figure out what our hypotenuse is. So we can use Pythagorean theorem, 3 squared plus that negative 5 squared equals c squared. So 9 plus 25, 34 equals c squared. So c equals the square root of 34. Now always check, ask yourselves, can square root of 34 be reduced? Do any of those perfect square numbers fit in? And in this case they do not. So we found our hypotenuse to be a square root of 34. So since everything is in terms of theta, which is right here at the origin, we can label our 3 sides. We know the opposite is over here, hypotenuse and adjacent side. And now if we just remember SOHCAHTOA, we'll be set. So sine of theta is opposite over hypotenuse. So if we look at our triangle, opposite is 3 over hypotenuse is square root of 34. Now we can't leave that radical in the denominator, so we rationalize. So 3 root 34 over 34. Now we can go ahead and move to the reciprocal function, which is cosecant of theta. And just to get this, we flip our sine function. Now if we flip this one right here, then we're going to have the radical in the denominator. If we remember, though, that this really was the sine value before we rationalized it, we can go ahead and flip that and get the same thing in the end. So square root of 34 over 3. It really just saves a lot of work, and I'm always all about saving work when I can. So now cosine of theta is adjacent over hypotenuse. The adjacent side is a negative 5 over root 34. So again, here we are rationalizing. Top and bottom multiplied by root 34, so we have negative 5 root 34 over 34. The reciprocal of cosine is secant of theta. Here's another case where if we flip our final answer here, we have the radical in the denominator. So let's just backtrack and recognize that that was our cosine function. So if we flip that, the radical ends up where we want. So square root of 34 over 5. Then let's make that negative because our cosine was negative as well. So last one, we have tangent of theta, which is opposite over adjacent. So opposite is 3, adjacent is a negative 5. So we have a negative 3/5. This one is nice because we don't even have the radical. So it's reciprocal cotangent of theta. If we just flip that, we have the negative 5 over 3. So those, your 6 trig functions using SOHCAHTOA, but in this case, we just had to plot the point, negative 5, 3, draw the triangle straight down to the x-axis, label your sides, Pythagorean theorem to get our third side, and then we were good to go.